here delta z upon z, z is x into y. So, dividing by x into y, y and y cancel out. So, it comes out to be delta x by x plus delta y by y. This is an average error in the measurement of physical quantity. If this physical quantity is the multiplication or the division of two quantities. So, we will summarize this slide again. Z is an physical quantity which is multiplication of these two quantities. So, the true value is Z is equal to x into y, while the its error or the average error is equal to delta z upon z is equal to delta x upon x plus delta y upon y up to so on the number of physical quantities we are considering. We already discussed that this is an average error, but instead of average error, if we want to take the standard deviation or standard error, then delta z upon z is equal to delta x upon x whole square plus delta y upon y whole square up to so on and its square root. So, standard deviation is always calculated like this: square of first physical quantity, second physical quantity and addition, and after taking its square root. Now, we come to the numerical portion of this type of physical quantity, which are the multiplication of two quantities. Z is an physical quantity which is given by W into X. W is 4.52 plus minus 0.02 centimeter and X is 2 plus minus 0.2 centimeter. So, we have to find Z and its error. So, we will calculate error depending upon average error or standard deviation. Z is equal to W into X. W is 4.52 and X is 2. So, Z is 9.04 centimeter square. Average error is equal to delta Z upon Z. Z is 9.04 is equal to delta X upon X plus delta Y upon Y. Upon calculating this thing, we will get 0.1044. So, delta Z is equal to 1.1044 into 9.04. So, delta Z is equal to 0.9 centimeter square. So, physical quantity Z is equal to actual value 9 plus minus 0.9 centimeter whole square. This is based upon the average error, but instead of average error, we will take standard deviation. Then delta Z is little different. It comes up to be 0.905 instead of 0.944. So, Z is equal to 9 plus minus 0.9 centimeter square. Next example is the division of two physical quantities. Z is equal to x upon y. X is equal to 2 plus minus 0.2 centimeter and y is 3 plus minus 0.6 centimeter second. So, this is the unit of length, this is the unit of time. So, division of these two physical quantity give the dimension of velocity. Z is equal to x upon y. X is 2, y is 3. So, Z is equal to 2 upon 3 is 0.6667 centimeter per second. This is the dimension of velocity. Now, we will have to calculate the average error based upon the previous results. It comes out to be 0.2 centimeter per second. While if we take the standard deviation, the error comes out to be 0.15. So, the using average error Z comes out to be 0.7 plus minus 0.2 centimeter per second. But if we take standard deviation, then error comes out to be plus minus 0.15 and its true value is 0.67. Next we come to the next rule, that is product of power. So z is an physical quantity which is given as xm plus yn, x raised to power m, n power m and y raised to power n. So if we take the simpler average error, then delta z upon z is equal to m delta x upon x plus n delta y upon y up to so on. And using standard deviation, we will get delta z upon z is equal to m delta x upon x whole square plus n delta y upon y whole square up to so on. Now we will do some numerical based upon all the combination like multiplication, its power. So these three are physical quantity W, A and Y. Its measurement gave the value 4.52 plus minus 0.02 centimeter, and A is 2 plus minus 0.2 centimeter square, Y is 3 plus minus 0.6 centimeter. We have to calculate Z, which is given by W y square divided by square root of A. W is 4.52 and Y is 3 and A is 2. So upon calculating this relation, we will get Z is equal to 28.638 centimeter square. So next we will calculate its error. Delta Z upon Z is equal to delta W upon W. Delta W is 0.02, W is 4.52 plus its power is 2. So 2 comes here, 2 into delta Y upon Y. Delta Y is 0.6, Y is 3 plus its power is 0.5. Square root of A means half, half means 0.5. So plus 0.5 into 0.2 divided by 2. So delta Z upon Z comes out to be 0.49. So delta Z is 0.49 into 28.638. So delta Z is 14.03 centimeter square. So Z comes out to be 29. So if we round off these figures, it comes out to be 29 plus minus 14 centimeter square for average error. But if we take standard deviation instead of average error, then the error becomes little different. So Z is equal to 29 plus minus 12 centimeter square for the standard deviation. Next numerical is the physical quantity Z is equal to Wx plus y square. This is same numerical portion as we did. We are given the error in the each physical quantity. We have to calculate delta Z based upon all these. Next we will calculate the uncertainty in the measurement of physical quantity S. S is equal to W cos theta. W is given as 2 plus minus 0.2 centimeter and theta is 53 plus minus 2 degree. So S is 2 into cos 53, it comes out to be 1.204 centimeter. But the largest possible value of the error in S is equal to the maximum value of W. Maximum value is 2.2, so W is 2.2, and minimum value of theta. Theta minimum is 51. So the largest value of the delta S is equal to 2.2 into cos of 51. So S plus delta S comes out to be 1.385. So upon minus S is 1.204 and S plus delta S is 1.385. So if we want to calculate delta S is equal to 1.385 minus 1.204, it comes out to be 0.181. So its result is S is equal to 1.2 plus minus 0.2. If we round off this, instead of 1 we will get 2 here because this digit is greater than 5. Next we take second method for the measurement of same example. S is equal to x cos theta, x is 2 plus minus 0.2, angle is 53 plus minus 2, same numerical but with different method. So here we use the method of differentiation instead of the simple method. If we take the differentiation of x, it comes out to be ds is equal to x differentiation is dx cos theta as it is plus x into cos theta differentiation is minus sin theta into d theta. So, upon calculating this error, we will get delta x s is equal to 0.126 centimeter. So, this is based upon the average error, but if we take standard deviation approach instead of the average error, then delta s comes out to be 0.120 centimeter. So, the total measurement gives s is equal to 1.2 plus minus 0.13 centimeter if we take the average error, but instead of average error, if we take standard deviation, then s is equal to 1.20 plus minus 0.12 centimeter. Next is simple numerical based upon absolute error, percentage error, relative accuracy and percentage accuracy. Given the expected voltage value across a resistor is 80 volt and its measurement is 79 volt. So, we have to calculate the absolute error. Expected value is 80 volt and measurement is 79. So, the difference of these two will give absolute error. E is equal to yn minus xn is equal to 80 minus 79 is equal to 1 volt. Percentage error is absolute error divided by its expected value. So, 80 minus 79 divided by 80 into 100, it is comes out to be 1.25 centimeter. A relative accuracy is 1 minus the relative error. So, it comes out to be 0.9875, while the percentage accuracy is the multiplication of this relative accuracy by 100. So, it comes out to be 98.75%. Next we come to the last portion, limiting error. The accuracy of the measuring instrument is granted with a certain percentage of the full scale reading. For example, a manufacturing may specify the instrument to be accurate at plus minus 2% with full deflection, full scale deflection. So, here comes the limiting error. Given a 600 volt voltmeter with an accuracy of plus minus 2% full scale, calculate the limiting error when the instrument is used to measure a voltage of 250 volt. So, the magnitude of the limiting error is, its percentage is 2%. So, it comes out to be 0.02 into 600 because the 600 volt is maximum value. So, the magnitude of the limiting error is 12 volt and limiting error for the 250 volt is 12.250 into 100. This is the limiting error for the 250 volt, 4.8%. Next is uncertainty in the measurement. There is no such thing as a perfectly accurate measurement. Each and every measurement, it has an error, may be due to observer, may be due to instrument or procedure. So, we will take again some example based upon percentage uncertainty. L length is given 21.6% and its error is 0.1 centimeter. So, the percentage uncertainty or percentage error is equal to delta L divided by L into 100. Delta L is 0.1, L is 21.6 into 100, it comes up to be 0.5 centimeter, 0.5%. Next example is the percentage error in the measurement of kinetic energy of a body when its mass and velocity is measured with a percentage error of 2 and 5% respectively. We know kinetic energy is given to be half mv square. So, the percentage error is delta E upon E into 100 is equal to delta m upon m into 100 plus, so the power comes here 2 delta V upon V into 100. It is given to be 2%, it is given to be 5%. So, 2 plus 2 into 5%, it comes out to be 12%. Thank you.